electric drive system. So initially we'll see about what is electrical machine. And electrical machines which converts electrical energy into mechanical energy is known as motor. We know that in respect of the construction there is no difference between the motor and the generator. A DC machines can be used either as a motor or as a generator. Generally DC machines are used for adjustable speed drives as well as constant speed drives, position control drives, control of motor drives with below and above the rated speed. The method of the control of the DC motor drives are simpler in design and less expensive when compared to other motors drives, and provide very good speed regulation with steady state starting, braking and speed reversals with a wide range of industrial applications such as those in paper mills, rolling mills, cranes, lifts, etc. So what is electric drive? The system employed for motion control are called drives, and the drives employing the electrical motors are known as electrical drives. So initially, see what are the prerequisites of the subjects. We should know about the concept of DC machines, AC machines, power electronics, and power semiconductor drives. So these subjects consists of 5 units. In unit 1, we will discuss about the dynamics of the electric drives. So here we will discuss about the fundamentals of the torque expression, speed torque convention and multi-quadrant operation of the DC motor drives. In the unit 2, we will discuss about the classification of the load torques and the steady state stability, load equation, speed control drives, classification and closed loop control of the drives. In unit 3, we will discuss about the modeling of the DC machine, steady state characteristics with armature and speed control, phase control DC motor drives, chopper control DC motor drives, and from the first to third unit, so it is the speed control of DC motor drives. And in the fourth unit, we will discuss about the control of AC motor, like your 3-phase induction motor and synchronous motor drives. So here we will discuss about the speed control of induction motor from the stator side and the rotor side, and also we will discuss about the control of synchronous motor drive. Also we will discuss about the operation of permanent magnet synchronous motor and electric motors. And coming to the fifth unit, so we will concentrate on the permanent magnet brushless DC motor and the single phase motors like stepper motor and servo motor. And these are the few books for this course, that is a power semiconductor control drives by G.K. Dubey, electric motor drives modeling analysis control by R. Krishnan, and we have another book like fundamental of electric drives, G.K. Dubey, and also very important books, that is the modern power electronics and AC drives by B.K. Bose. So these are the objectives of this course. So you can understand the basic electrical drives and their analysis, learn the design of controller for drives, understand scalar control of electrical drives. You can understand the starting and braking method of electrical drives and learn to work in times while working on engineering problems. So after the completion of the course, so you can able to model and simulate the electric drive system and design and modulation of the power electronics converters and drives, design appropriate current and voltage regulators for electrical drives, implementation of the various variable speed drives in electrical energy conversion system, and you can analyze an existing electrical drive system. So before going in details, we'll discuss about the what is linear motion and translational motion. In linear motion, we know that force is equal to mass into acceleration. That is the expression telling about the F equal to m dv by dt. So here F is the force in Newton, m is the mass in kg, and v is the velocity in meter per second. So then in case of rotational motion, we will discuss about the torque. So T equal to developed torque T equal to J d omega by dt. But T, this is also called the electromagnetic torque or developed torque, so in Newton meter, and J is the moment of inertia, and omega is the angular velocity in radian per second. So in case of motor, the input is electrical and output is mechanical, and here the load is mechanical load. So T is the developed torque or the electromagnetic torque. So in this case, the load torque is always opposite the developed torque. So any motor load system can be described by the fundamental torque expression, which is equal to T equal to TL plus minus first derivative of J omega m. So if we will differentiate here the variables J and omega of the two variables, so ultimately we will get the total torque T equal to load torque plus these dynamic torques. So if for the constant moment of inertia, the term dj by dt equal to 0, so we will get T equal to TL plus minus J d omega by dt. So in this case, the positive sign represents the acceleration of the motor, and negative sign represents the deceleration of the motor. So the acceleration and deceleration depends upon the sign or the magnitude of the motor torque, electromagnetic torque, and the load torque. So if the electromagnetic torque is greater than the load torque, then we will get the acceleration. If T minus TL less than 0, then we will get deceleration. If T minus TL equal to 0, then the motor will run at the constant speed. So already we have discussed. So during drive accelerates or decelerates depending upon whether the electromagnetic torque is greater than or less than the load torque. So during acceleration, the motor just supply not only the load torque but also the dynamic torque. So during deceleration, the dynamic torque has a negative sign, therefore it assists the motor torque or it assists the electromagnetic torque. So we have various types of loads. So it may be, so let's say in mechanical load, the load torque can be classified into two categories: active load torque and passive load torque. So what is active load torque? The load torques which have the potential to drive the motor under equilibrium conditions are called active load torque. So such load torques usually retain their sign when the direction of the drive rotation is changed. Torque due to the force of gravity, hoist, lifts or the elevators, and the locomotive trains also torques due to the tension, compression or the torsion undergoes by an elastic body comes under this category. So next we will see the passive load torque. So load torques which always opposes the motion and change their sign on the reversal of motion are called passive load torques. So the torques due to friction cutting is passive load torque. After that, we will discuss about the characteristics of the different types of load. In electric drive, the driving equipment is an electric motor. The selection of the particular type of motor driving and machine is the matching of speed torque characteristic of the driven units that of the motor. Different types of load exhibits the different speed torque characteristics. We will discuss in the next class.